Hello everyone. I guess I'm live now. Mm, Yes, I am. Let me just share the link with others. Hello everyone. I guess no one is here. Anyways, so let's start with what we are supposed to do today. Can just anyone write in the chats if everything is working correctly? This is the first time I'm going live on YouTube actually. So if anyone can, it will be great help. Okay, so I guess uh, there is a warning anyway. I don't have a very good system to stream directly, but yeah, it works right now. Okay, so as you all should have understood by now that by the title that we are going to make something like this, that is obvious. So today's project, as I had posted earlier in LinkedIn, that we will be creating a system monitor. If you can see my LinkedIn, that is the image of that. But okay, so we are actually going to build that system monitor today. Let me SSH into my Raspberry Pi. We will be doing this on my server only in this folder. Let me first show you the example that we will be making today. This is that thing that we will be creating today. So this is purely in C with all these colors, this animation here and everything. So let's get going. We will be doing this in this folder. There is only a notes, but this is an outdated notes. I will need this notes here, and let me spin up a Tmux session that will help me see my notes. Okay, that's a very long list of things. Let me just open it. Okay, so these are the notes for this session. Basically, what you just saw, we will be creating that thing. Let me see if everything is fine here. Stream bitrate is very low. I don't know what that means. Anyway, so we will be creating that system monitor as you saw just now in, in a few seconds back. Okay, so let's start and see how we can make it. So these are the notes that I will follow. These are the particular information that we will be scraping from this site. Uh, just a minute. I guess I will see some viewers here now. So this is the system monitor that we are going to make. So basically we will be creating this in my Raspberry Pi, and I'm using Tmux for my video multiplexer, sorry, terminal multiplexer. Anyway, so this is a clean blank folder where we will be creating all the files. So one by one we will pick up all the information from this Linux host, and we will display it on the screen. I will be referring to these notes for all this information and how to parse them, and these are some things that will help us in this life, because I don't want it to go extremely long, because if I keep on writing all this will take long. Let's see how far we can create this. So the main takeaways from this live should of yours should be, uh, what are the files that store certain types of data that you can scrape, and then how you can use multiple colors in a C program. Means as you just saw, there was colorful output here. If I show you once again, I had colorful output here, and so how all this came here, how I parsed all this information, how to like set this state in a certain way, all these things we will be learning in this live, and using these colors and everything. And after learning, you yourself can structure this whole dashboard to look even better than this one what I'm showing you right now. So let's start. First we have to first I will scrape the first line, that is the architecture, the host name, and the zone info. These are the things that are very easy to scrape. Let's see. Okay, so first the architecture dot c. Okay, there are certain things that we need to do here. Okay, so this is my first live, so I'm just doing certain things. Okay, for architecture, and here we will deal with multiple C files. Okay, that multiple .c files that will have shared functions. To scrape our architecture, first we will need to have the file that contains the architecture, and the file is this one: sys devices system CPU model. We will take this file and put it here. this file will be used to scrape the that value. Let me show you. This is the contents of the file, and architecture of a system means this, whether it is ARM, Arch, x 64-bit, 32-bit, all these things. So let's just do it. We define this file. Now I will define a function that will take that system out, take that information, architecture. Okay, so when we are working with files, there is something called a file pointer object that we have to use here, FP, and this FP is included here, hash include FC and DL. This is, I guess, file control. Anyways, so this FP will contain a reference to the file, to this file that will give us this information. So how we do it? Fopen means file open, if I'm not wrong. Arch means the architecture file in read mode. We are opening this file in read mode, and we have to also have a variable. Let's say buff. Now this size variable is not defined anywhere in the program. So we have to create a header file, a custom header file for this particular program. Okay, first write it. What was that? Functions.h. We have to create this header file for our program and define certain constants. If I define here size is, let's say 255, because we will need this in other contexts as well. Okay, let's go to architecture and include this file, include functions.h. Okay, one question I want to ask all the viewers, when we are importing fcntl or stdio.h, when we do that, we use these angular brackets, but when I imported a custom header file, we are using double quotes. What is the difference between these two? If anyone is watching, you can just write in the chats. I will know that you are watching. That is very helpful. Anyways, so we defined size, file open. Now we have to read it. For reading, there is a function fgetS that reads the file into buff for the whole content and the file pointer. Now if I print it, print buff, sorry, not to be, it will be n. If I print buff, this should contain this whole string, but this cannot be printed because this whole program does not have a main function yet, main method. So I'll create a main.c. I'll include functions.h to have that other defined functions here, and here I will write int main. This will be my main function, and here I will call the function architecture. But this will not work right now because here for printing we have to include stdio.h. Now this should work. We are compiling for all the star.c. There is some error here. Architecture is not defined. Sorry, I forgot to define it here. The prototypes must be defined in the header file so that the other referenced file can find it. If anyone is having any confusion, you can just write in the chat. I will clear it if I'm going very fast or anything you want to say. Please write it in the chats. I will know that you are watching at least. As defined 255 is okay. Buff undeclared, but why? It's in architecture, right? Architecture. Why care buff with undefined? Wait, let's see what's the error. As defined size expected here. Okay, so there should be no semicolon here. Now, what's the next error? Okay, it didn't give any error right now. Let's see if we are getting that whole information. Yes, we are able to scrape this whole information. Now we have to just take out this part for the architecture. So going back to the architecture file, we got fgetS, and now I will also take a temporary variable here, because every time when we will be extracting each and every token delimited by this, we have to extract each and every word here delimited by this colons. For the third word, we will take the third word here. So for that, we have to save that somewhere. Let's say temp or buff is the place where we will save it. So okay, we will save that new word in the temp. For that, we have to copy strcpy hash include for using string functions, because string copy is a string function. So you have to include string.h. Copy into temp str token. You have to token buff with a delimiter colon. Now if I print temp, it should print CPU. So if I just copy it for CPU type, and then comes the architecture, this should have the architecture printed. Okay. Oh yeah. For the str talk function, for the first call, it takes the actual string that needs to be tokenized, and for the subsequent calls on the same string, it takes null values such that it tokenizes each and every part. So we got the architecture from this thing. Now, since everything is happening from main, and these three things, the hostname, architecture, and time zone, does not change of a machine, we will save this architecture in a arch, such that there is no naming conflict. In a variable here, we will pass this variable functions. This will accept a variable of type char star, and in architecture, this part, it will okay, am I live, right? Yes, I am. So here it will also accept another arch variable. Let's go down, and instead of printing temp, we will just copy this into arch, the temp value. So here we don't need stdio, but I will keep it for now. That's that if there is anything messed up in the future, we can fix it. Let me see if this can be printed here. Set as arch, and for that I have to include stdio.h for printing. Now compile it, and perfect. So we are getting arch 64. Now we have to get the host name. Again, we have to define a function here, but this time we will do it just as we did in case of architecture. It will again be the same host name, which will be cat star, and we will take hostname.c. We will define the file that contains the hostname, and it is etc hostname, the very common file in etc hostname. Let me just show you. If I get this file etc hostname, this will contain just the host name of this system. As defined host, this will be etc host name. And what are the things that we need here? We need hash define, not define, hash include. We will need functions.h, because all the prototypes are defined here. And also we will need stdio.h to print here. For the time being, we will need stdio, we will need fcntl.h for file controls, and we don't need anything else as of now. So let's do it. Hostname, the prototype is like this. Again, we will use a buffer to save it. File pointer to get a reference of the file. Host in read mode, and then we will open it. F get s, we will get the thing here. F get s, we will get it inside buff for the size, and from where we are getting it? We are getting it from the file pointer. Let's see if everything works fine or not. Sorry, if everything works fine or not. I guess it will. For buff, and for main we have to call this host name, and it will also need a variable to save. Host name will take the parameter of host. So this is start.c. Let's see. Okay, no errors. We print it. We are getting Raspberry Pi as the host name. But as you can see, here is a new line. We don't want this new line here. Without this new line, it will also create some problems, but we don't need this new line at this point here. So what we can do, we can for this we have to include the string header file, hash include string.h and str. Wait, this is a character array, right? So we can just do it like buff strlen buff -1, sorry, buff -1, not here, -1 equal to this single null character. This will just shift the end of the string by 1. Now if we run it, there is no extra new line. What I did here, if you want to know, just write in the chat. I will explain what I did there to remove that extra new line. So when we have all the data right, let's take it in a host and send it to the main. strcpy, take it from the host and send it to the main. Okay, if is my voice clear? I'm not sure if I'm speaking loud enough. If I am, please write. If I'm not, then also please let me know if I'm speaking loud enough for you all to listen. Because in this screen there is nothing that I can understand whether I'm speaking live, means loud enough or not. Okay, so we are 25 minutes into the stream and we already have two metrics that we had to scrape, and we are doing it right. For main.c, we got the hostname but it didn't print it yet, so let's print it to check. %s tag in for host. Yes, we are getting it. Okay, and now it's time for the time zone. Time for time zone. Funny. We will again hash define the zone file, that is etc slash, let me just revert it, etc time zone slash time zone. Okay, so here are also the basic imports. Include what was that, functions.h, and since we have to print or work with files, rather let's include fcntl.h file control, and we will see if we will need the that, what do you say, strings or not. I can see two people are watching. If you can just write in the chat anything that will just encourage me. Thank you. uh, you can write whether I'm speaking loud enough or not. Oh, and I understand that screen is very tiny. Now say if you can see it. I increase the font. Is it visible? I guess yes. Okay, so here I have time zone. Okay, forgot what I had it there. Okay, I didn't define any time zone file here. Sorry, time zone function. This is cat start. This will also take a cat start. Now we will edit the time zone file. Cat start zone. This is buff. Again, we will take. This is why we created multiple files such that we can contain each logic in its own separate file. And this will become even more relevant when we will move further into more complex tasks, more complex matrices, not matrices, matrix. So for file, we will open, in this case, it's basically the same thing everywhere. We open a file, we read the data and we parse that data into meaningful information. That's why it may seem a little monotonous to you if you are watching this, but this is how you gather system information. It's about your system. It's not relevant for everyone, but it is relevant for those who want to work with servers, system in IT infrastructure, and networks and all that stuff in Linux, and also basic knowledge of C Linux is also important for you. So we scrape the start time zone and let's put it in buff here. Oh, okay, by the way, all the functions I'm using here, this fopen, fgetS, hashdefine, everything can be found in the man page. If you want to learn more about them, you can read them and what are the parameters that they take, you can refer to the man page. And now if I print it, okay, let's not just print it, just trust it one time and directly send it to the main file. Let's call it here, architecture hostname, and arch host and zone. Zone will also be a file, and here the function was time zone that takes the variable zone, and if I just print it here right now, percentage slash n and zone. Okay, in star.c, okay, I did something wrong in time zone. Time zone, strcpy. No, I did something wrong in main. This will be printf. Now let's compile it. Functions.h. Okay, I misspelled it. Functions.h. What is happening? Okay, I used STSCPI but didn't include the string. So these things are very common while working with programs. These errors will come. What now? File fcntl. What's the problem here? stdio.h. Why? fopen zone r fgetS. Okay, stdio.h. Let's take it as well. Now if I print it, Asian Kolkata, here you can see there is again a new line that we need to trim out because we don't need that thing here as of now. So it will buff strlen of buff -1. This one line trims out the last new line that gives us a room for us to create our own new line. Now we got this data. Now we have to show it in this manner, like we had seen in the demo. Here, see at the top, the architecture and all the things are changing, so we have to put it like this. Okay, and this text can just mess up sometimes, so don't worry about that. We have to show it in that animation format. So what is the logic behind it? The logic is put the color in white. That's a very simple logic, and every 3 seconds change the text, change the text, change the text. That's the main logic. So for that we have to take this part from the notes and take it in our application. Let me explain. This clear command clears the whole screen because we can execute system commands in C using the function system, which is included in stdlib.h header file. For goto, there are certain particular sequence of strings that can be used to change colors on the screen and to perform multiple operations. Like we can change the position of the cursor to our requirement, we can bold text, we can use backspace, reset, and everything. So these are the basic data that we will use. I just do a no number to copy all this thing here, copy, and put it in functions.h. From here I will use all this data. So first we will go to main, and instead of printing them like this, okay, we will need stdlib for hash include, not stdlib, unistd.h for sleep. And why do we need sleep? As I said, we will be changing them per 3 seconds. So this will go on continuously while one, that means run continuously. This is some basic PIM power that you can use while running continuously. You have to we have the information about architecture, hostname, and time zone. Go to this go to function sends the cursor to a particular position. I will say 0, 0. Print this thing, architecture. But before printing, put some, make it, uh, put some designs into it. What are the designs? Backspace, that means take the cursor to the complete front of the line, such that every time you print, the program will print, it will print on a fresh line. Make the text bold, make the text bright white, and after printing, reset everything. When everything is reset, it comes back to normal. This is important, because when you cancel the program, it should come back to normal. And before printing everything, clear the screen so that it can start from a fresh screen. I said go to, and now you can sleep for 3 seconds. Again, go to 0, 0. I will show you this go to function, but put a backspace, make it bold, make it bright white, and reset it. And since this is host, so you will write host name. And here also same. Okay, we have to make it sleep for 3 seconds. You can adjust this time according to your own preferences. I can see few people watching. If you can just write hi or something, I will just know who is watching this live, and I will be more encouraged to make even more in the future. Backspace, bold it, color is bright white, and reset. And for here it is time zone. And again, sleep for 3 seconds. I think this should do the animation there. Okay, this did not work because we have to include std_lib.h standard library, and now we can do 2, 3. Hostname is Raspberry Pi. Time zone is Asia. Again 3 seconds, and we are doing a animation with colors and design in pure C. That's the power of C. No fancy framework, no fancy language, no high level language, just plain basic C. You can create this kind of dashboards. Now let's move on to the next part. There is also something we can add on to this program, like a signal handler that will trigger this clear screen and put the cursor at the top whenever whenever we are sending a signal. And also this is happening right in my Raspberry Pi. So this is happening actually on a production server. Okay, so we did this. Next up, we have to scrape that time and date. As we had seen here, we did the hostname architecture, the first line. Now we have to scrape time and date. This time and date comes from one single place. I will show you from where, and we have to make them, we have to differentiate, means separate them. Let's see how we can do it. This comes from the, if we, okay, there is no other screen. Sorry, who detached it from the session? Oh, let me just reattach it. Okay, I just pressed the wrong key bindings there. So when we issue the command date, it gives us all the information about date. If I just watch it, see, it will give us for every 2 seconds. This runs every 2 seconds. Can run it every second. Every second, this date command updates, giving us the day of the week, the date, the month, the current time, the time zone or the time format means IST whatever, and the year. We have to scrape all this information piece by piece and format it in such a way the way we want it to show or express. So let's do it. Vim date.c. So for date, we have to hash define uh, date as date. This is the command that we will be executing. As we all know, everything is in Linux is a file. So even a command that we are executing can be read as a file. You will see it here how to do it. We have for a date that will do the whole thing. Oh, okay. From now on, all the functions will be in their own threads because as you can see, as you have seen in the demo, everything updates in its own time. They are running completely separately from all other metrics. So they will be in their own thread without clashing. Let's see how we can do it. For putting it in a thread, we have to make it a pointer. Okay, for date and this from here, everything will be printed in its own function. We will not take anything in the main. So here we will also have a file pointer, but this time we will not open it here. We will open it inside a loop that will run for every second to scrape the information. Okay, we have to include certain things here, like the mandatory thing, the functions.h. It's already 11. We are 1 hour into the thing. Okay, 42 minutes here into this. Include functions, include stdio because we will be printing it from here. Include unistd.h, Unix standard. What else do we need? We need fcntl hash include fcntl.h. We will need string. We will see if we need string, we will include it. So for now, we have this. We need a buffer that will store everything, and we will need all the fields that this date function that this date command returns. So we need a day of size. We need date. Date means the date that is 8. That is also size. You can optimize this by reducing the value of size or using custom lengths for how much data a variable or a character array can hold. That is a string. So for now, for a month, I'm just doing it because this is easier for now. Hour of the day, that is 23 right now. Hour, minute, but I can do this because everything will be reused every time. Second, how many second? Let's say this format. I don't know what this is called. If you know, you can just let me know in the chat. And which year it is. As I said, every second it will change. So we can sleep for 1 second. Every second it will change. Now the main part. fp, that is the file pointer, is popen. Popen means until now we used fopen. Fopen means file open. Popen is process open because whenever you are executing a command, it becomes a process in the memory. So we are opening the process here. Process is date. That will be replaced by the process name date, and we have to read it. We have to read it. we get the data fgets into our buff for length size, and it is fp. From fp we are getting the data into buff. Now getting the data into buff from fp. Now we have to tokenize this. As I had said earlier, we have to tokenize every part to extract that data. For that we will be needing hash include what string dot h. And for tokenizing, what we will need first, we will tokenize the day, strcpy tokenize day strdok. We will tokenize buff on the basis of a space. Okay, and I will yank this and keep on pasting it for, let's say, 1 2 3 4 5 6 7 8 times. 1 2 3 4 5 6 7 8 times, and every buff will now be changed to null. What happened? This should have changed to null every buff. Okay. Sorry about that. We will take it out and again select shift I null, and yeah, everything is changed to null. And here I will just keep on changing the variable day, date, month, hour, minute, second, the format, and the year. Now we have to print it in a proper structure. We will write a goto because there I want to put my cursor. For first we will print the time. As you can remember, in our last example it is in 350. This location, this coordinates, you can hit and trial which one you like the most, and you can print it according to that. No problem in that. First we will be printing the time, and how to do it. Time, the color for it was bright yellow. Backspace it, hold it, bright yellow, and we have to reset it. Now that information is time, percentage, 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 %s. And now you have to include the data, hour, minute, second, format. Let's see if this works or not. Okay, I didn't call it there. Is it there in functions? No. Let me add it there. Void start date. And yeah, as I said, this will run in a separate thread. So also we have to create threads here now. pthread.h. So I will create size number of threads here. pthread underscore t threads for the number of sizes. And now we created this. Let's print it. Let's start a thread, pthread So to create, what does it take? It takes a threads value. The second parameter is null. Third parameter is the date. It's the function that we want to call, and fourth parameter is also null. And now let's see if it works or not. Any problem? Time zone error. Redeclare the different kind of symbol, but where? Okay. So apparently in thread we are getting an error for the function time zone. No problem. We can just rename it to zone info or anything like that. Zone. Here time zone will become zone info. And in time zone, this will also become zone info. See, no problem. Okay, something is wrong here. Let's see what. It should be wrong in the time zone file only. etc time zone. Sorry, not in the time zone file, the date. Here, it should be wrong somewhere here, but what? What can go wrong? For the date, we are executing date. Yes. Fget we're getting it. Okay, let's see what's wrong. Let's go one by one, and now you will see how to debug a code. I don't need any of this thing. I will just comment out everything and just print the buff if it is working. Printf. Let's see if this thing works. Sorry, for date to put let's see if this works. Yes, the date is working. That is fine. So what's the error here? What's causing this trouble? That's how you uncomment everything. Okay, so let me see what is the trouble here. One space. Everything will go to null. Fine. Time S. Everything is cat star only. So what's the problem? I think so 1, 2, 3, 4 and 1, 2, 3, 4. Okay, I am also sleeping for 1 second. No problem in that. I'm resetting the thing. I'm going to this line. Is it problem with these two? I don't think so. It's again faulting. So let's see date. Where is it going wrong? Is it going wrong somewhere here? For the date, let me just do it for the date. It's fine. I will just keep on printing all these files until I find the error here. Printf. I can printf again. Day. Let's see if this works. It's Saturday printing. Fantastic. No problem in that. Now the second point. Date. This should also print. No problem in that. 8. Perfect. Now the month. Okay, so whoever was watching left. Anyways, as I said, I had to do it. It's March. Perfect. Something is wrong with the time values. Hour, minute, second. Year is okay. After month, it comes the hour. Okay. This is the error. So whenever we are taking the time, it's coming as a whole string. We have to even tokenize this thing. This was the error. This is how you solve all these errors. So after date, month, we get a time, and then so in place of hour, we have to take time here. Wait, we have to take time. Minute, second will come later, and then we have to take format. Yes, strcpy format str doc null for space format and then year. Here, right? So take it from here, time, paste it there. Here. Okay, no, not there. Here. Here we came to here. Now we have to tokenize time again. strcpy in hour tokenize time based on colon colon time hour minute second. Perfect. And remove this thing. Now this thing will work. This thing will work. It will. Just sorry, I don't know what this is. So where it was, Mr. CPI for our hour, I didn't give any semicolon. Thank you for your lovely comment, Oshim. You have to compile it and okay, why is it buffering like that? Maybe, yeah. So as you saw in the output, it was buffering like that, means it was printing after 3 seconds because I didn't give this new line here. Now if I do it, it will work on its own time. This is a error that I learned when I was doing it. This is an error that I learned when I was actually preparing for this thing, that whenever the buffer is not full and you do not use a new line, the program will not print anything, or it will wait for the buffer to be full. This is something you have to take care. And now we have to print the date. We print the time. Let's print the date here. For date, I will go to 5,0. And once you know how to scrape the information, it's just a matter of putting your cursor in the right place and printing the line in proper decoration. That's it. There is nothing more to do with this thing. Backspace it, bold it, bright yellow it, something, reset it. And for that, now we have to print the date. Date comes in percentage. This is the format of my choice. you are free to use your choice of the format. It's absolutely fine. This is the way that I prefer to print it. That is month, then date, then year, then day. This is my preferred choice, and your choice is completely up to you. The way you want to customize this whole output, you can. Okay, this went to a new line because 2025 contains a new line. Let's fix it. How we can fix it? We have to go back to date, and I know that the year value contains it, so I can just change it strlen to year -1 is equal to a new line. Sorry, another character. Wait, something is wrong. Okay, perfect. So we are moving closer to the output that we are expecting. So we did architecture, the animation part up there, host name architecture, everything. We did the time, we did the date. Okay, can anyone just tell me if my voice is clear or not? Yes, it is clear. Anyways, so now let's move on to the next part. Next part, I myself forgot what it was. Let me see from the already prepared thing. The one, get it out. It was the uptime. So let's take the uptime here. For the uptime, it's proc/uptime. Uptime, it's proc/uptime. In this file, you have the uptime information. But this information is not the way the others were. Proc/uptime. Here, there are two times. We have to take this time, which is in milliseconds, and I also have this handy formulas here that can change this time into human readable format, and we will use these. I will copy them here. Sorry, I will copy them here, and now let's do the uptime.c hash define uptime. It's proc/uptime void uptime. Okay, this will also be a function pointer because this will run in its own thread. The includes that we need here are stdio.h hash include fcntl.h hash include what else what else standard input fcntl unistd because we will be using sleep and let's see okay, we will also need strings string.h, and how can I forget my functions.h, the custom header file. Okay, so here we got all this. Let's go to this uptime, sorry, to this uptime thing, and every second it changes uptime, so we again have to take it inside the loop. The time is char buff, sorry, the time we have to take buff that is of size, and the time will be stored in integer. We are removing the dot part because that the decimal part, because that will be more complex to handle. So for now we will just store it in temp, sorry, in as an integer in time variable. So every time it will run as an infinite loop. Sleep for 1 second. Read from this file everything that we are used to be doing, we are doing since the beginning. we will read from this file uptime in R mode, and we will take the first field. So for that, buff doc str doc will take for buff and by spaces. So this will take the first field and put it in buff. Next, we will assign it to time using a to I, ASCII to integer. This is buff. And for a to I think we have to import stdlib.h. Let's see if the time is being printed properly or not. Recent t time. Let's see if this is actually what. Okay, for functions we have date, we have now we have void uptime, and we will call it here as well as in a different thread such that it can go on. That's one. The next thread for date it was uptime and null here. Let's see if there is any problem. Okay, something is wrong in uptime. Proc/uptime. Let's see what is wrong here. Okay, this is not Python. I guess this thing should work. Okay, this is again giving us a fault. Uptime. What is the error here? Doing it correct. This is working, but whenever we are str, we are talking it, right? Okay, let's do it like this, because the first element str tokenizes, it puts it in that variable only. This works, no error as of now. So let's time it and then print it. Why is it coming 0 every time? It should not come as 0. Time, right? Time is being used as load. Let's fix it. Why is it coming 0? It should not come as 0. T, yes, it is T, it's integer. Let's see if I can, if I just print buff, what it is coming. Sorry. Nothing. Why nothing is getting printed here? Sorry, not date, it was uptime, right? So before printing, we have to, let me just place it in its right position. Go to 0357, this should be 7,50. Now print it, and for the uptime I was using the same yellow color. So backspace, put a backspace, make it bold, make it bright yellow, and reset it. And let me just style it. Uptime is this thing. Now let's see what it gives out. Uptime, but nothing is being showed. Why? Isn't it reading from the right file? We created a file pointer. We opened it for up uptime hash define uptime proc/uptime. Yes, that was the file we are supposed to read, like, right? Yes, that was the file we are supposed to read because it is changing every second. /proc/uptime. And it is being read as a string. So what's the error here? File if open uptime in read mode. Okay, no error is there. We forgot to put the data if getS that were used to be doing here into buff size and fp. Then we are tokenizing buff time. This should work with tag t time. Let's go. Perfect, it's working. Now I have to just change this whole thing into a calculation. Okay, cancel it. Okay, from now on I will just paste the calculation because they need some they are pre-calculated for formulas. These are the formulas, you can note it down, that converts this millisecond time. Okay, the time that is being provided by that file is in milliseconds. So these are the formulas that actually changes that time into a human readable format. Now if I change it to these many days, hours, minutes and seconds, this uptime is shown. Days, minutes, hours and seconds. 4% D become 5D. I have to write here %D, and instead of time it will be days, hours, minutes and seconds. So for 4 days, 13 hours, 28 minutes and 44 seconds, this server is running continuously, hosting your favorite applications like Cutlo.starnix.in, cloud.starnix.in, my own portfolio, podstar.starnix.in, or you can say that yourear.starnix.in. That's the site that I didn't write about yet, but I will in some time. So we did 4 lines. Now we will take the temperature and the cooler. Let me just see the format in which I had them out there. Okay, now the cooler, then temperature. And there is one more annoying thing that's happening here that I need to change, that when I cancel the program, it should clear the screen automatically. So for that, I will take signal.h and write a signal handler here. Handler that takes a signal. And what it does, it basically just clear the screen and exit the program with status code 0. It's fine. And now I have to register the handler here. Signal for sigint. I'll just use an autocomplete here, and for sig term also I will use autocomplete. Done. Now I forgot if they need function pointers, so I will just refer to the man page of signal, a standard C library. It takes a void signal handler. Okay, and it should be a void star pointer. Okay, so let me just change it to a pointer here. Signal takes the pointer value. Now if I see this thing, okay, maybe not a pointer it takes. It's compiled. Now if I run it, it's working absolutely fine with every data updating in its own pace, no collision, nothing. And when I say Control C, it wipes out everything. Fantastic. Now cooler and temperature. Let's do the cooler. Cooler is basically the fan that is running on your server. There can be multiple fans. In my case, I have only one active cooler that is running, the Raspberry Pi active cooler. So I will show you how to scrap that data. It's similar for all other devices. Cooler dot hash define cooler, and the file that we will use is this one. For cooler, it is sys class thermal cooling device, and for temperature, this is class thermal zone. Sys class thermal cooling device. Let me show you what these files look like. If I cd, okay, I don't need to cd sys class thermal and cooling device 0, because I have only one cooling device. These are the files that are present there, and we are interested in the type, current state, and max state. Type is also not something that we will need right now, but we can get it. Type is PWM fan, because it's an analog hardware fan that is running on my Raspberry Pi. Type is this. Current state is 2, that is it is running in second speed, and the max state is 4. That means it can run up to speed 4. Max state is 4. So here we will take the current state and the max state. Cooler, the file that we will be using is sys class thermal cooling and underscore device 0 slash cur state. This is the current state of the cooler, and we will define another thing. Define cooler max, because that's what we need to compare and contrast. Class thermal cooling underscore device 0 and max state. Void 8 cooler. Here we will need certain inclusions. Hash include, first of all, the functions.h. I don't remember if it was functions or function. Anyway, don't care, we can fix it. It is stdio.h. These are the basic inputs that we will need. stdio.h, fcndl.h. I think these are the only two, or anything else. We will find it, we'll figure it out. So I need one file pointer to open the max file. here, and char max will be, sorry, size, and char will be size. So I don't need this huge variable, but it works. If getS is the same for everything, I will take the max here and fp file pointer. Now I got the max, but the current state every time it changes, so that's why you have to take it every time. How it happens? For fp, I will again use the same variable to point to a different file, fp cooler in read mode. Now if getS max and current size in fp, and now printing part, printf how backspace cold. Since it is cooler, so we will use bright blue. I guess that was the name of, yes, bright blue is present there. Reset, and the format will be cooler %s / %s new line. You can customize this output in any way you want. It's just that I'm showing you how to do it. You can customize this output in any way you want it. Okay, this will go to 9,0, and the sleep is not given here. Let me include the sleep for 1 second. Perfect. After up, okay, I had it open here, that's why I showed that. Okay, after uptime we have to void cooler, right? Main.c pp thread create. We will create another thread here, threads +2 uptime, and now it becomes cooler null. Okay, still no one is watching. Anyway, this is my first live, and I'm expecting better response from the next time if I can complete this properly. Star.c, and sleep is not there in cooler, so cooler unistd I have to enter here, unistd.h. The program that I'm doing here in one sitting, it previously when I did it for the first time, it took me like 1 month to create this whole thing. It's 2x4 because current state is giving us another new line. So let's fix that. If we want to fix it, after taking char str len of char -1 is equal to this thing, and since we are using strlen, we have to use string.h, string of so many mosquitoes so, and we have the cooler. It is running at 2 speed out of, means the max speed can be 4 as we have regulated in our fan, and it has a max speed. This is also kind of the same. Now we will scrap temperature data, means what is the current temperature of my server, because servers can get hot quite easily. So we will now scrape the temperature data. For temperature, what we can do, it's again that everything that we did here is this class, but this time it will be class thermal, and it will be thermal zone. And if I ls this, there are too many files. We need a few files here. The type, the temperature, that's the current temperature right now. So here we have cat type. Type is CPU thermal. This is the CPU temperature of my server, and actual temperature is this. This temperature is should be divided by 1000. It is in milli-degree Celsius. So if I divide this by 1000, I get the main degree Celsius thing. I said it right? Milli-degree. Yes, it is in milli-degree Celsius. We have to change it into Celsius by dividing the whole temperature by 1000. So for now, it's temperature dot c hash define temperature sys plus thermal zone 0 temp. This is the file that we will be reading. Void start temperature hash include stdio.h hash include. I will need fcntl.h hash include unistd.h hash include. I don't know, I'll figure it out later. So for the temperature, what we are getting, we'll again need a file pointer and a temperature variable to store it. Other than that, a temp, okay, we can use buff here, and for the temperature we can use some float value temp. Why float? Because we have to divide it by 1000, so it will return a float type. And we have to use a to I, a to f. Let's see if that gives an error. While one, sorry, I'm just having a little runny nose. If open, we have to open the file and take temperature in it in read mode. Now when we are reading the temperature, we are reading it in here. Okay, now let's change it into a to f equal to a to f ASCII to float. I will change. Okay, we have to first load the value into buff file pointer. This is buff a to f. Let me first normally print it if it works or not. 07 9 11 50. Sleep and sleep for 1 second. Every second it will check whether what is the temperature. Backspace. Mosquitoes. Bold it. Bright red because it's temperature we are dealing with, so it is red. And the temperature is percent f, right? Float new line. Let's see what we are getting here. In functions, we have to add this cooler. Now we have void start temperature and in main we will pthread, create another thread here, threads plus 2, then 3, null, temperature, null. Let's see if it works. There is a lot of things on. Didn't I? Oh, I didn't include the functions. So let it be here. And A2F implicit declaration. So where is it originally? It is in standard C lib library. Okay. No issues. Just link temperature. And include stdlib.h. C.c. Okay, I'm getting it in float. Now let me just change it to, means divide it 1000. Now I don't know how to insert the degree symbol here, so I will write degree Celsius. That's how I do it. Okay, it's giving a lot of values, lot of decimal places, so we can just limit it by saying give me up to 2 decimal places. And we also scraped the temperature. Now we are, means on that point we are actually converging with our original example data. Means the example I showed previously, the example, the structure that we are following. So we scraped every possible, not every possible data, but most of the data. Now 2 more scraping is left, that is the memory and the CPU. For memory and CPU, it's very easy. We have to just take 2 or 3 parameters and put it, means 2 or 3 values and set it there. CPU is a very problematic thing, not the memory one. Let's do it. So now we have to see in my notes also, you can see CPU is the greater one, not the memory. Memory is a very short thing. Memory, the formula is, where did I save the memory? No, I didn't. Okay, anyways, so memory is, let me show you first where it stores the data. So memory stores the data in proc/meminfo. If I show you this thing, cat, I cat it proc meminfo. This is the data that it stores, your Linux system. Here we will not need everything, we'll just need memory total, that is in kilobytes, how much memory you have, and memory available, that is the amount of memory that is free for you to use. There is a difference in mem free and mem available. Mem free is the unused RAM, and memory available is the RAM that is used previously, but now it can be used again. So we will take mem available, mem total, and do our math. Okay, and since it is in KB, to convert it into GB, we have to divide it by 1024 into 1024. So for memory.c, it's already like we are 1.5 hours into this live, and we did most of the work right now. If you want, you can take a 5 minute, the viewers want, they can take a 5 minute break. I will just start again in some time. Okay, so I'm back. Let's took a little 1 minute break maybe. So let's continue with the memory section. We will complete the memory part and then the CPU part, and then the program will be over. And then I can sleep. I was not well for the last 1 week anyway. So for memory, let's do it. We will define the memory file, that is rock and mem.info, right? Void memory. We will have this file. This will also be read every time because memory usage changes in the machine at runtime. So many mosquitoes. Okay, so we will open the file memory in read sleep for one. This is a common thing that we do. Okay, for now, as I showed you here, okay, the screen is the go. If I show you here, rock mem info, every line contains a data, a key value pair. So there are certain steps that we need to follow. First, we will pick up the line, the mem total for the first line. Let me show you what I'm trying to say. So for saving the data, we need a buff. I accidentally turned on caps lock. Of size something. And now here we will take the data. fktest every time takes one line from the file. So buff size fp. At this point, buff contains mem total colon this whole line. So we have to also we will need two variables, total and available. Okay, we can also calculate free available and used this thing. fgetS, now we will need strtalk to get this part. If you have any confusion understanding any point of this video, you can comment down. I will explain, because live is not being watched by anyone. So if you are watching this in future, you can comment down. I will try to explain whatever your doubts are. This will print data. This will handle files. This will sleep. Okay, so and this will use string functions. And how can I forget functions.h. fgetS, we got the data. Now we have to use strtalk to get this number. So how can we use that strtalk? First we have to remove this mem total, and then we have to go to this number. So that is another thing that we need, a temporary buff to hold the intermediate values. See, I'm also doing this with you. It's not like I know everything here. It's like I'm also learning with you. So there are some mistakes or maybe an explanation error that you are facing. So if you are facing something like that, you can just tell me that this part I need to explain or something like that. I will do it again and again, no problem with that. So we got fgetS, str cpy. We will change it, means we will take it to temp, and what we are taking here, we are taking str talk buff based on space. For first time it will take mem total, this string here, it will take this string. For the second time it should take this thing. So let's try, and again we will do strcpy in temp to str talk null, because we are tokenizing the same line. And so here, let's just fix the place, the 11, it should be 13 now, 13, and that one is 15 for CP. Printf, the printf will be backspace bold bright magenta, really magenta, reset, and memory used by total. This is how the whole thing will be, but for now we are just, since we are just testing it, we will test it only temp variable. Let's see what is it giving us. They cancel it. No. Function say I will include a void star not temp memory write main.c pthread create threads plus 4 null memory and null. I hope this does not create any errors. And file one null pthread create. Okay, that's a very petty error, no problem with that. Okay. Okay, so we are actually getting the total memory, as you can see here. Yes, we are actually getting the total memory. Now we have to take the available memory. We did str talk to get the total memory. Now we will again be doing if getS for the second line on buff size fp. We will again take it fgetS, because as I said, every fgetS call takes one line from the file. So first time we got this line, second time we got this line, but we need this line, so we will call it 3 times. And we are taking it buff size fp, and we will repeat these steps again. So I will just copy them. Okay, better not, because Vim sometimes does some weird stuff with this copying. strcpy in temp str tokenize it buff space, and again strcpy, because we need the value temp str talk tokenize it based on space. And if I just show you, so it is not colon, it will be slash, it will be temp temp. For now we can just test, for the testing phase we can do it. Yes, we are getting the ever changing data here. If I show you, and yes, we are getting the ever changing data in the memory. Come to the bottom. Now we have these two datas here, I will take the total equals to, no, it will not be int, it should be float. Total is a to f temp by, because it's in KB, we have to convert it to GB. 1024 by 1024. Not I there. Why should I there? And then it's total and available. And what is available? A2F temp by 1024 plus 1024 done. And here used by total we are using. So used is, okay, this will be F point to F point to F and GB GB space space. This is total minus available. And so I don't need this used variable here. Total minus available is used, and then total. Let's see if this works or not. Okay, A2F is not declared. It is what we're doing, memory std lib include std lib.h. Oh man, it's capital hash input std lib. I think this will work. Yes, I guess it's working. The value is changing definitely. Temp memory. Oh, sorry, this will not be temp anymore. This will be total. Now let's see. Yes. So total and available. This is the memory that is being used by my system right now. 3.87 GB out of 7.86 GB, because that is my Raspberry Pi 5 8 gigs version. So it's accurate. The data is accurate here. So we also did the memory part. Now it's only the CPU part that's remaining, the CPU usage. So if I just show you in the original thing, or in the original program, it's always 0%, because the not all programs use that much CPU. I don't run so many intense tasks there, but let's understand how to calculate this thing. Okay, for CPU, if you see, CPU is in proc/stat. This is, so to scrape CPU data is very problematic. At least I thought so. Let me show you what this file looks like. This is CPU data, and you have to understand and decode from here. It's a very tough thing, but let me explain as much as I can. So I have this 4 cores in the CPU, this quad core CPU of a Raspberry Pi, and this is an overall metric of the total CPU, right? So each core, all these fields, this is a field, this is a field, this is a field. There are 10 fields here, and all these 10 fields are named. I don't exactly remember their name. The names are user, nice, system, idle, iowait, interrupt, soft interrupt, steal, guest, and guest nice. So these are different types of CPU times that is being used, and we will one by one extract all these things. And this is a very long process, so to keep things short, I copied this whole thing from the original program and I will just paste it there, right? So these are the fields that file provides us the different CPU times. So the logic is you take the difference between two CPU times, because CPU time is cumulative. It accumulates over time and it only increases. So you have to take the difference between two times and print the data. I have this whole thing here ready. I will just paste it there. So let me just create the basic functionality of this thing. CPU.c, time for the CPU, the ultimate thing. How long? It's already been 2 hours. CPU prop slash stats or stat. It should be stat, not stats. One stat. White star CPU. Okay, if someone is watching, you can just write in the chat who you are. I will be more like enthusiastic or energetic to know who is watching my live. You just can write something. And it will again need the same kind of imports. Sorry, it's C, it's not Java that I will import. Java or Python. Includes stdio.h hash include fcntl.h, then stdio fcntl function copy file control unistd.h, functions.h. Is it too small for you to watch? Okay, I think this is right. Anyways, so now let's start it. We will need the file pointer as usual, and we will need all these values here, all these variables. I will just copy them from here and but we yank it, and they're all integer values, right? So I will just put after them integer values, but wait, I can copy this whole thing using power of tmux, and I can paste it. Done. And for char means for reading the file, we will need a buff. Every time we will read the file, let me see if it coincides. Okay, we will read it. CPU previous. Okay, so basically we need a structure here because the whole thing is contained in a structure. Struct, it's type def struct int this thing, and its name is CPU fetch. That was the name, I guess. It was okay. That's on me how I want to name it. CPU usage works. CPU usage. I need two variables here, prev and car. Now it goes on the same file one sleep for 1. That's what I did there, right? Yes, sleep for 1, and then okay, I already have this sleep for 1 here. So let me just now go and copy this whole thing. Okay, something is wrong. I will just take this whole thing here. Wait, just shrink it. Debug sometimes does all this problematic thing. Copy it, go to the program, shrink it, and paste it. Now I can increase it. Okay, so let me just explain what I did here. For CPU usage, I created two variables. First, I opened the CPU, means the file, read from it the first line because I'm only interested in the overall CPU usage. I read the first line. I took all the space separated values into one by one, one by one, one by one. Then for the total CPU time, I had to sum all the values except the guest and guestness because they are related to virtual machines, which we are not dealing with here. For the idle time, it's idle plus IO wait, and for the active time, it's previous total minus the idle time. And I made the CPU sleep for 100 seconds, not the CPU, not the program, CPU for 100 milliseconds or microseconds. This is microseconds. Then I again opened the file, read all the information, and took all the values. Now I had to calculate the delta. So I calculated the delta there, and with bright magenta color, I simply showed everything there. Oh, I had this memory thing here. I didn't see it before. I had this memory thing saved, but I don't need it right now, so I can just remove it. Okay, this will take long. Let me just do it fast. So I guess the CPU is also done, and you understood what I did with the CPU. If you didn't, I will make a dedicated video only on parsing that stat file. CPU main pthread create threads plus 5 memory is CPU again null. I hope this should work. This to work. What? Okay. I understood. So I had these extra members there, total, active, and Italy. Don't take offense, please. This is not anything offensive. Because I had to calculate the total idle times, but idle was already a parameter, means a variable here. So I had to use, means I changed E to I. No offense, please. I didn't mean any offense here. But yeah, this was fun. Hope it compiles idle data. Okay, so these deltas need to be added here, and the deltas it just was a here. Yes, it was a normal variable, not a part of the structure. Guessed nice. And where was the delta thing? CPU proc UBSTT. Yes, total delta, active delta, and I guess there was some idle delta. Idle delta. I guess this should work. Okay, A2I str took. So FCNTL percentage is here A2I, that is stdlib dash include stdlib dot h this, and there was some. Okay, here I don't give the semicolon. str talk, that is string. Worked, and it's 0%. It is 0% because the server is not using any CPU time. Maybe it's 0.0000 something 1-2%. That's why it's not showing here. But yeah, we within 2 hours 2 minutes we did this. Okay, sometimes it just creates a little problem. We created this monitor in real time in a live video using pure C, nothing else, and it is updating in real time, and every part is updating in its own pace. So the date, time, and memory or temperature or cooler is not really related to anything. They are updating in their own time. So yeah, that was it. And I maybe you learned something new about colors on terminal, how to make your cursor move around. Okay, this let me show you this, how I made the cut, how this go to work. So this is the particular sequence here. This dd means I'm changing the values here. This d and d, this particular syntax is used to move your cursor to a particular position, and these are the escape, these are actually escape codes. These escape codes are for colors, to change the colors. This escape code is to move your cursor, and these are some basic things that I used in this program. So yeah, this is the thing. I hope you learned something, you enjoyed it, and maybe you are watching this in a later time. So thank you, and I will end this live now. Thank you for being my audience. And I had said in LinkedIn that I will do this live, and I did it. So yeah, thank you. Good night, everyone.